When we're symbolizing objects on a map, there are a lot of different ways that we can represent objects and differentiate them from each other. For example, if we were putting some points onto a map, we could change the shape from a circle to a square to represent two different objects that we're representing on the map. Similarly, if we have different sizes, like different size cities, we can make the size of the symbol larger and larger to represent bigger and bigger cities. The thickness of the line might represent something like how major of a road or a highway one is, and the line type might represent whether, for example, it's an unpaved road or a highway, or that symbol is not shown here, but maybe for a railroad. And we can also use colors, patterns, and of course the font that we use in order to label things. All of these things can change in size, thickness, color, and other attributes in order to differentiate different things that we put on the same map. So when we're talking about color, one thing to keep in mind is that we typically use this HSV, or hue saturation value color model. The hue represents the color circle, or all the colors in the rainbow. So red, orange, yellow, green, blue, violet. And we actually set this with a numerical value that varies between 0 and 360. The saturation is how rich or intense the color is. If it has 0 saturation, it's going to look white. And at its richest saturation, it's going to be the purest of these colors, like this nice pure blue here. And the value is how dark it's going to be. So we can get a darker and darker blue by changing the value until we get to the color black here. So this is one simple way that we can intuitively change colors, and it's useful for many different applications. Another color model we sometimes talk about is the RGB color model, or the red, green, blue color model. And in this, we vary values, all three values, from 0 to 255. And in this example here, red would be 255 for red, 0 for green, and 0 for blue. And here we would have 0 for red, 0 for green, and 255 for blue. So this would be pure blue. And then we can start combining the colors. For example, if we combine red and green together, 255 red, 255 green, and 0 blue, we would get this yellow color here, because that's how color mixing works. And if we make all of them 255, we get the color white, and all of them 0 would be the color black. And just by varying those three numbers, we can come up with any color. Sometimes this isn't as intuitive as the HSV color models, because we can't say that by changing one of these colors we get, for example, a little bit lighter of a purple. So how do we actually use colors to represent things on maps? Well, one thing we can just say is every category we have on a map has a different color. So for example, these could be the colors of all the different states in the United States. And we could have 50 different colors, or we could just use a smaller number and just repeat the colors for non-adjoining states. But let's say we wanted to represent something like the population density of a state. Then we might do something like this, where we start with the least populated states being the lightest red, and then we go to this darkest red, most saturated red, when we have highly populated states. But sometimes we want to show things going from one direction to another. So for example, if we knew the average income per state, we might make it this kind of medium color here. And then for states that have a much higher than average income, we might make this a darker blue. And for states that have a much lower than average income, we might make that a orange color here. So in that way we can see the average in the middle, and then we can see how we're diverging or moving away from the average in both directions very clearly on a map.